I'm going to be a bit of an introduction on what happened during commissioning, and then we're going to jump into different instruments, and at the end we're going to have a Q&A. So first of all, a little introduction to TSO commissioning. During commissioning, we perform some observations to determine if science and instrument modes, first of all, were properly working to enable measurements of precise flux variations in time, which is the typical goal of TSOs, and also could be calibrated to allow for just precise TSO. So if something couldn't be calibrated, these observations could serve for us to, take an extra set of calibrations or identify them to make that happen. And we use some transiting exoplanar observations to reach those objectives. You may be wondering, why didn't you use like a flat line or like using binary? Well, we thought about that, and that was in the plans. But it turns out that you can't beat these planets because there's two main reasons. One, the transiting exoplanets are very, very thoroughly characterized because you're all very interested in these objects. And this goes both by studies on their stars, companions or contaminants via adaptive optics imaging, for instance, and via multi-observatory data. So there's transit properties can be very, very well known. And the second is that variation as a function of wavelength, both out of transit and in transit, can be sort of controlled. So we chose systems for which the wavelength dependence of the transit depth was predicted to have negligible variation, the precision levels of the instruments, so that we could test them. So the commissioning targets were actually two. The first one was HAT P14b. You already saw this data that was released yesterday. This is a massive planet for which the scale height is very, very small, so you expect like a flat line in the transit spectrum. And this was observed by NIRCam, NIRISS, and NIRSpec. So there's three instruments observed the target. And one little detail which is important is that it has a nearby well-characterized companion at 0.85 arc seconds. So this is a diluting contaminant in NIRISS sauce, so you can't get rid of it. So you have to deal with it. And there's also the NIRCam show wavelength. It's also impacted by this little companion. But again, heads up. The second one was used by MIRI. It so happened that HAT P14b was not as bright for MIRI, so that's why they didn't use it. So they had to choose another target that was bright in the mid-infrared. So this one is a small planet, but the large density, it's 2 times the Earth. It also implies like a very small scale height, and any variation should be below the noise level. I'm putting in parentheses here after the instruments the program IDs in case you want to check the phase 2s, like the files for the programs, or in case you want to download the data if you haven't downloaded it already. Of course, there's some bonus TSO targets that were not initially part of cycle 1. The first one that I'm putting here is BD601753. This is actually an A-star that was taken during commissioning, and it was observed by NIRISS sauce, so this should be a flat light curve, and actually that's what we measure. And there's 2 extra targets which were like the early release observations. So WAS96b, which probably you've heard already about it, transit spectrum that shows some clear water features, also observed by NIRISS sauce. And there was actually a backup target for the EROs, which was HAT P18b, which has some nice surprises if you want to look at that data set. One important caveat, however, is that this data has like a small companion that you might want to be careful about and correct for in your data analysis. Before moving forward, I want to give some caveats on this TSO data sets. So we just finished commissioning last week or 2 weeks ago. And there's some caveats that you have to be aware of. First of all, the commissioning data timestamps in the in times table have a small drift of about a few seconds. So if you try to measure precise timing, you'll see a small drift, 3 seconds I think it was the delta. And this is only an issue with the commissioning data sets. The ERO and the second one data, it's fine. This will be reprocessed in the next few weeks. I'm going to tell you where to look at to get all these processing updates. The second one is the timestamps in the in times are modified Julian dates, just FYI. And any conversions, because we provide the in times, both provide modified Julian dates, but also converted to barycentric Julian dates. All those conversions are in the headers. And the third heads up is that the HGA moved header keyword. So there's a keyword in your data sets that says, if a high gain antenna movement happened during an observation, that's currently given false in case in which there have been moves during observations. So we really recommend you download the telemetry data and have a look at this directly. We have I'm going to explain it a little bit, JDocs. We have a JDocs article on how to do this, and this will be fixed in a time slot TBD. I'm going to give you a very brief tour through JDocs because we really, all the instrument teams, the JWST project, and within the TSO working here at STI, we did like a very, very, very hard work on figuring out and giving you all the information in the JWST documentation. So please check it out. This button right here, when you open JDocs, this button is going to be your friend in the next few months. Please check it more or less routinely. The breaking news will provide any updates that we make to JDocs in the next months or so, which you should expect some changes. There's two parts of JDocs that I really want you to focus on, or that I would really recommend you take a look at. The first one is under proposal preparation. There's some methods and roadmaps, and there's time series observations. Here, this has all the information, in particular the TSO noise sources, has all the information on the noise sources that we've been finding during commissioning. So it's a very, very useful set of information. Also, how to monitor spacecraft telemetry. There's some Python code even that you can use to, download when did my HEA move happen, etc. So all the little details just go here and they're there. The second portion that I really wanted to focus, also to give you a focus on, it's under data, there's a space that it's called calibration pipeline caveats. And under that, there's a time series observation pipeline caveats, which speaks about all the caveats that we have seen on the pipeline for TSOs. How the data is segmented, what happens, what's with the timestamps, and also we have actually little articles for each instrument that go in detail into what you should pay attention to into the instrument. So please check it out. And if you see anything new, or if you want something included, please, there's ways to reach to us. If you don't see something here that you figured out, we have JDocs, but we also have the JWST help desk. So if we can help you in anything, we're here to help. An expert will contact you swiftly. So please be sure to have these two links in hand.